All right, now let's talk some practical stuff that we can do. Talk about some practical stuff we can do. Let's go back to the budget constraint. Budget constraint's going to be our buddy. We're going to get as much mileage as we can out of the budget constraint. So my budget constraint is the sum of the xi pi equals m. Right? Everybody agrees with that? And now I'm going to look at what happens changing everything at the same time. I'm going to change x's, p's, and m's. Right? So I'm going to shift from one equilibrium to another, changing both prices and income, and letting people respond by changing their mix of consumption. So it's just a total change. So total derivative of this is the sum of xi dpi plus the sum of pi dxi equals dm. Okay? Everybody agrees with that, right? Yes, no, maybe so. Okay. Then I'm going to take that equation and I'm going to divide by the budget constraint. Just divide through. So then I'm going to get the sum of the xi dpi over the sum of the xi pi plus the sum of the pi dxi divided by the sum of xi pi equals dm over m. Okay? So this side, okay, is the percentage change in income, right? That's the percentage change in nominal income. And what I want to say, I'm going to call this dp. That's the change in prices. And I'm going to call this term here dx and equals percentage change. I'm going to make a delta. It's percentage change. Delta p plus delta x equals delta m. And I'm going to say this is the percentage change in prices, this is the percentage change in consumption, and this is the percentage change in income. And I want to call this price change, quantity change, and this is the income change. So I want to think about the budget constraint tells me that if I increase income by 10% and I increase prices in the aggregate by 3%, then real consumption could go up by 7%. That's really what this says, right? Sort of, it's a way of dividing it up. And I want to ask you a question, which is, which one do I want to think about? Why is that a reasonable way to think about the change in consumption or the change in quantities? Any idea why that's a sensible measure? Why we measure, why economists might say, that's a pretty good way to measure the change in consumption. Okay, yeah, but more fundamentally. Think about it. That is, I'm weighting the quantity changes by prices. Why does weighting the quantity changes by prices make sense? Why should I rate something that costs $10 twice as much as something that costs $5? Yeah.
Equilibrium, that's how much you value.
Exactly. This, in fact, can be thought of as a first-order approximation to the utility function, right? That's what we did in Lecture 1. In Lecture 1, we showed that the sum of pi dxi is a first-order approximation to the dollar value of the change in income. In consumption, right? It's a first-order approximation to the utility function. So And to first order, this is going to accurately measure whether his consumption in real terms is going up or going down. Right? We're going to be looking. How much does he value each good? How much did each good change? We're going to total up over all those goods. You got a +1 times $10, and a -1 times $5, and a +2 times $12. And you're just going to add them all up. And you can say, well, that one was worth 12 plus, this one was worth 17 minus, and I'm going to add them up. And I'm going to say, based on what I think his values of the different goods are, he's better off or he's worse off. It's a first order approximation to the utility function. Right? What about this term? Measuring how prices have changed. It says I'm going to weight each of the price changes by the quantity consumed. Why does that make sense? First off, you should realize if this one makes sense, that one's going to have to make sense. And if this one doesn't make sense, that one can't make sense. Everybody realizes that. You can't have an equation in which this makes sense and that doesn't, because this is what it is. Anytime you decompose something into two parts, first part makes sense, second part has to make sense. First part is wrong, second part, right? Everybody understands. They add up to the truth. If they add up to the truth and you underestimate one, what must be true? You overestimated the other one, and vice versa. You can't, if they add up, you can't be right on one and wrong on the other. Okay? All right. But independent of that, independent of proof by elimination, why do we think that makes sense? What in the world tells me to measure whether prices are up or down by weighting the price changes by the quantities? Well, what would be the perfect measure of whether prices have gone up or down? The ideal measure. What would measure price changes perfectly? Yeah.
The maximum utility consumers could achieve at
Yeah, but what function measures whether the cost of living goes up or down? How about the cost function? That might be a good idea, right? The cost function measures the cost of obtaining a given level of utility. So a perfect measure of the cost would be C of P1 up to Pn U bar, right? What would a first order approximation to the cost function be? How do you take a first order approximation to a function? Well, it's C of P1 naught up to Pn naught U bar plus, what's a first order approximation? You take the sum I equals 1 to n, partial C, partial Pi, right, times dPi. Everybody agrees with that? And a first order approximation is just the function at the starting point plus the derivatives times the changes in the prices. Everybody agrees with that? What are these? What's partial C, partial Pi? That's xi. So this is sum from I equals 1 to n of xi dPi. So the reason this term makes sense is because it's a first order approximation to the cost function. Okay? So when we got a bunch of prices changing at the same time, we want to ask did prices go up or down. We're going to weight those price changes by the quantities consumed. Yes?
That equation then that you first decomposed is a first order approximation itself.
It is.
Yeah.
So but what I'm saying is I could have split this up numerous different ways, but I split it up, this split, to say this is quantities and this is prices, has a virtue in that this is a first order approximation to the utility function, and this is a first order approximation to the cost function. Okay? People understand how that works?